Hello everyone. In this lesson, we will be illustrating the extreme value theorem. Okay? But before that, we will try to define first the notions of the critical point and the extremum of a certain function. Then after that, we will proceed with the discussion on this theorem, the extreme value theorem. And this theorem is very important, especially in solving problems on optimization kasi magagamit talaga siya. So you need to really understand this one so that we can solve optimization problems. Okay? So first, let us have this definition. Let f be a function that is continuous on an open interval I containing x sub o. Then we say that x sub o is a critical point of f if f prime of x sub o is equal to 0 or f prime of x sub o does not exist. So, ibig sabihin, si x sub o ay critical point if yung derivative ng function at x sub o is equal to 0 or the derivative does not exist at all. So, kailan siya does not exist? So, after you evaluated the derivative, dapat hindi siya undefined. Or, referring to the graph, the derivative of the function does not exist if there is a sharp corner or cusp at that point on x, which is x sub o. Okay? So that's it. And we say that the maximum occurs at x sub o if the value f of x sub o is the largest among all other functional values on the open interval I. That is, f of x sub o is greater than or equal to f of x for all x element of the open interval I. This is self-explanatory. When we say maximum, it is the largest among all other functional values. Okay? On the other hand, minimum is the smallest among all other functional values on the open interval I. That is, f of x sub o is less than or equal to f of x for all x element of the open interval I. And lastly, an extremum of f occurs at x sub o if either the maximum or the minimum occurs at x sub o. Therefore, when we say extremum, it refers to either the maximum or the minimum value. Okay, so extremum is the general term for the maximum or the minimum value. Okay, so let us now proceed to these theorems, the Fermat's theorem and the extreme value theorems, they will help us solve problems in finding the critical point and the extremum of a certain function. Let us have first the Fermat's theorem. So what does this theorem state? So we have here, let f be continuous on an open interval I containing x sub o. If f has an extremum at x sub o, then x sub o must be a critical point of f. So meaning, yung sinasabi lang niya, if the extremum of the function, meaning the maximum or the minimum, occurs at x sub o, then x sub o is already classified as a critical point of f. Okay? And we have the extreme value theorem. Let f be a function which is continuous on a closed and bounded interval AB, then the extreme values of f always exist, and they occur either at the endpoints or at the critical points of f. So EVT is an existential function, meaning there will always be an extreme value for the given function if that function is continuous on a closed and bounded interval. So whatever that closed and bounded interval, there will always be that extreme value. And that extreme value usually occur either at the endpoints or at the critical points of f. Okay? So para mas maintindihan, let's consider the following examples. Find the extremum of the following functions on the interval -2 and 2. So this is a closed and bounded interval, negative 2 and 2. So from here, since we are going to find for the extremum of the function, therefore, we need to solve first for the critical points and the endpoints of our function. Since according to the EVT or the extreme value theorem, the extremum always exists and it occurs at the endpoints or at the critical points of the functions. Now, in this case, since the interval is already given, then we already know the endpoints, and that is negative 2 and positive 2. They are our endpoints. So, in this case, we need to solve na lang the value of the critical points of the given function. And for letter A, our function is f of x equal to 3x squared minus 3x plus 4. So, finding the critical points of this function, we need to solve first for its derivative, right? So let's differentiate this one. So f of x equal to 3x squared minus 3x plus 4. Using the power rule and the sum or difference rule, we can actually have f prime of x equal to, so this will become 6x, right? So 2 times 3, then 2 minus 1. So you have 6x. Minus, derivative of 3x is just 3, and derivative of 4 is just 0. So therefore, the derivative is equal to 6x minus 3. Now, according to the definition of critical point, the critical point occurs when the derivative is equal to 0 or the derivative does not exist. In this case, the derivative always exists because wala namang way para maging undefined itong derivative natin dito, right? So therefore, we will just consider yung values ng x na makakapa-0 sa ating derivative. So in this case, we will equate the derivative to 0. So this will become 6x minus 3 equal to 0. So the derivative is equal to 0 now. Then let's solve for x. So we will have 6x equal to 3. So I added 3 both sides. So this will be the result. 6x equal to 3. Then solving for x, we will divide both sides by 6. And we will have x equal to 3 over 6 or just 1 half. Okay? Now, you check if that value of x belongs to the closed interval or the given interval. In this case, 1 half is actually an element of the closed interval negative 2 and 2. Therefore, x equal to 1 half is a critical point. So we say this one is a critical point. Okay, so we already solved the critical point of the function, which is x equal to 1 half. Then we will now compare the functional values at the endpoints and at the critical points. Whichever is the largest and the smallest will be the extremum of the function, or meaning that will be the maximum value and the minimum value. So let us now compare. So let just have a table of values. So we will have here the value of x, and we have f of x. Okay, so we will evaluate the function at the endpoints and at the critical points. So our endpoints are negative 2 and 2. So we have negative 2. Then we also have the critical point is 1 half. And the other endpoint we have 2. Then let's evaluate the function at these values of x. So first, we have negative 2. So what you are going to do, you substitute your value at the original function. Okay, so we will have f of negative 2, and that will be equal to 3 times negative 2 squared minus 3 times negative 2 plus 4. And this will now be equal to 4 times 3, you have 12. Then you have positive 6 and plus 4. And this is equal to 22. So therefore, our function, the value is 22. Next, let's have 1 half. So 1 half, f of 1 half will be equal to 3 times 1 half squared minus 3 times 1 half plus 4. So we will have 1 half square is 1/4 times 3. You have 3/4 minus 3 halves plus 4. And this will now be equal to over 4 LCD. So you have 3 minus 4 plus 4, right? And this is equal to 3/4. So therefore, this one here is equal to 3/4. And lastly, for f of 2, we have f of 2 equal to 3 times 2 squared minus 3 times 2 plus 4. So this is now equal to, this is 12 minus 6 plus 4, and this is equal to 10. Therefore, this is equal to 10. So from that, we can see now the maximum and the minimum value. And you can observe here that the maximum is 22 and it occurs at x equal to -2, and the minimum is 3/4 and it occurs at x equal to 1/2. So this is the maximum, this is the minimum. Okay, so that's it for letter A. So we have the maximum 22 at x equal to -2 and the minimum value 3/4 at x equal to 1/2. Okay, now let us try the second problem. And we have f of x equal to x cubed minus 9x squared plus 15x minus 20. So the same pa rin yung gagawin natin. Let us first look for the derivative of this function. So we will have f prime of x here. And this is equal to derivative of x cubed is 3x squared. Derivative of negative 9x squared is negative 18x. And derivative of 15x is 15. Derivative of negative 20 is 0. So we will have this one. And as you can see, there's no value of x that will make this one undefined. So therefore, we will only consider the critical point when the derivative is 0. So we will equate the derivative to 0 here. So we will have 3x squared minus 18x plus 15 equal to 0. Then after that, since this is a quadratic equation, we will solve for the value of x through either of the following. We can actually use factoring, we can have quadratic formula, or completing the square. However, in this case, I think this one is factorable, so we will just factor this one. So we can have 3. Let's factor out first 3. So we have x squared minus 6x, and we have 5 equal to 0. Then after that, we will have the factors of x squared minus 6x plus 5, that is x minus 5 and x minus 1. So we have equal to 0. So from that, we can now actually solve for the value of x. But you can actually divide both sides by 3 para mawala na yung 3. Okay? So dividing both sides by 3, ayan. So what's left is x minus 5 and x minus 1 na lang, and 0 over 3 is still 0. And from that, we can now solve for x by equating both factors to 0. So we have x minus 5 equal to 0. Therefore, x is equal to 5. And x minus 1 equal to 0. Therefore, x is equal to 1. So from that, we actually have two critical points. So we have solved two critical points. However, we need to take only those critical points that is within the given interval. Now, in this case, 5 is already beyond 2. So, therefore, we will not consider x equal to 5. So, we will not take this one. Instead, we will only take x equal to 1 since 1 is an element of the given interval. So, x equal to 1 will only be our critical point. Okay? So from that, let us now compare, kagaya kanina, compare the functional values at the endpoints and at the critical point. So these will still be our endpoints. So we have x here and we have f of x. So therefore, we have -2, then we have 1, then +2. And so there. Then let us try to substitute it in our original function. So you have -2 cubed minus 9 times -2 to the power of 2 plus 15 times -2 minus 20. And if you are going to evaluate that one, the answer will be -94. So there. Then you try to substitute 1 cubed minus 9 times 1 squared plus 15 times 1 minus 20. The answer will be -13. And for 2, the answer will be -18. So from that, you can actually now see which is the maximum and sino yung minimum. So from here, you can observe that -13 will be our maximum and it occurs at x equal to 1. And -94 is our minimum and it occurs at x equal to -2. This is our maximum value and this is our minimum value. Okay, so that's it. And for the last one, let's try letter C. We have f of x equal to x minus 3 times x to the 1/3. So the same process pa rin yung gagawin natin. So we will try to get the derivative first. So f prime of x will be x, derivative of x will be 1 minus derivative of 3x to the 1/3 will be 3 times 1/3. So you have 1. Then x to the 1/3 minus 1 is -2/3. So as you can see here, we have a negative exponent. And I can actually transform this one into positive by just taking the reciprocal and change the sign to positive. So therefore, I can have 1 minus 1 over x to the 2/3, right? And from that, I can combine the two terms. So I can have the LCD is x to the 2/3. So we have x to the 2/3 here. So we can just multiply by 1. Then minus x to the 2/3 divided by x to the 2/3 is 1 times 1. You have 1. Okay? So as you can see here, this will now be our f prime of x. This derivative will become undefined or it will not exist if the denominator will become 0, right? So we will consider the critical point when the derivative is the DNE or it does not exist. And this fraction will only be 0 when the numerator is 0, right? So when the numerator is 0, this will become 0 because 0 divided by any number except 0 is 0, right? So therefore, we will consider the critical point when the derivative is 0. So, dalawa yung titingnan natin. So, what we're going to do, we will equate both the numerator and the denominator to 0. So, equating these two values here, we will have x to the 2/3 minus 1 equal to 0. And we have x to the 2/3 equal to 0. This is for the numerator. This is for the denominator. Then solving for x, just add 1 to both sides. So you will have x to the 2/3 equal to 1. Then solving for x, para mawala yung 2/3, maging 1 yan, we will raise both sides by 3 halves, right? So this will become 1 to the 3 halves also. So x to the 2/3 to the power of 3 halves. So we will have 2/3 times 3 halves, that is equal to 1. So x to the power of 1 na lang yan. So we have x equal to 1 raised to any number is equal to 1. So we have x equal to 1 as our first x, value of x. And here, the same pa rin, we will raise this one by 3 halves. This one also. So we will have x equal to 0 raised to 3 halves is still 0. Okay, so we have two values of x's here, 1 and 0. And we need to make sure that those values um, are within the given interval. And I think 0 and 1, nasa loob yan ng -2 and 2. Therefore, we have two critical points here. So we will take both x equal to 1 and x equal to 0. And these are our critical points. Okay? And let us now compare the values through table of values. So we will have x here and we have f of x. Okay, so we have the endpoint -2, the first critical point 0, then 1, then we have 2. Now try to substitute x equal to -2 to our original function. So that will become -2 minus 3 times -2 to the 1/3 using your calculator. The answer will be positive 1.78 approximately. Okay? When your x is 0 naman, you will get 0. Okay? When x is 1, so 1 minus 3, yeah, -2. And for 2, substitute using your calculator, the answer will be -1.78. So as you can see here, we can now determine the maximum and the minimum value. So first, the maximum will be 1.78 and it occurs at -2, x equal to -2, and the minimum value will be -2 and it occurs at x equal to 1. So this is our maximum and this is our minimum. Okay? So that ends our discussion on the extreme value theorem. So I hope you have learned something here because we will apply the concepts that we have learned here in solving optimization problems. Okay? Thank you for watching.